In this video, I will explain what is a random variable and what is the definition of random variable and what is discrete random variable and what is continuous random variable and some examples. So we can start. Random variable. A random variable is a set of all possible outcomes from a random experiment. So random experiment is an experiment or a process for which the outcome cannot be predicted. Cannot be predicted. Such experiment is called random experiment. Its outcome we can't predict earlier. Such experiment is a random experiment. So we can find the possible outcomes. We can say the possible outcomes. So if we have a coin, we chose a coin. So we can't say what is the outcome. What is the exact outcome. But we can say can be head or tail. So such experiment is a random experiment and that outcomes say that random variable. But random variable is a numerical expression of an outcome. So we got in the case of coin, we got head or tail. So we can't write down the outcomes in this manner. In these outcomes, we can change to the numerical value. Then only we can find its probabilities and distributions, etc. So we need to convert a numerical value. That numerical value is called random variable. Okay, in many real circumstances, we interested to find outcomes of random experiment. But then random experiment, the outcomes of random experiment is converted to numerical value. That numerical value is called random variable. If there has an experiment, there exists their outcomes. But we actually interested to represent the outcome as the exact outcomes because that's an event like a head or tail or uh, etc. So it's like an events. But we think about their numerical values, corresponding numerical values. Such real value is called random variable. Okay, so we can define the random variable. Random variable is a function that is mapping of the outcome of experiment to numerical value. So we have a random experiment. After the random experiment, we got some outcomes. So we define a function from these outcomes to numeric value. Okay, such function is called random experiment. These outcomes we called sample space. These numerical values are coming to the real numbers. So we can say random variable is a function from sample space to real numbers. Okay. So the image of this function is subset of real numbers. Okay. I will explain one example. So we have a coin. We have a coin. That coin toss a coin 6 times. We have a coin. That coin tosses 6 times. We need to find the random variables of number of head. Come up. So define X from set of outcomes, sample space to real number. So the head throws 6 times. So each times we got a head. No head come up. Okay, 6 times. In these two extremes, so many outcomes we have. In these two extremes, so many outcomes we have. We have H, 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 T. Sixth outcome is tail. And fifth outcome is tail. Fourth outcome will be tail, etc. And all are tail except sixth outcome. All are tail except fifth outcome, etc. So we can define a function and this sample space has no heads come up. T, T, T. So that is mapped to 0. One head come up. H, T, 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 T. Similarly, second throws only head and all others are tail. So many fixed outcomes. Only head outcomes, 6 outcomes we have. So that mapped to 1. Similarly, 2 outcomes, 2 heads, 3 heads is possible, 4 heads, 5 heads, and so all outcomes are heads. All throws are heads. So 6. So we can say the variables are sample space to real numbers and x of s is images can be 1, 2 to 6. Okay. So these are the variables related to number of head come up. The next example is a box of 6 eggs is rejected once. It contains one or more broken eggs. So we have 10 boxes. We have 10 boxes. And each box contains 6 eggs. So one of the box rejected if at least one egg is broken. So we have 6 eggs in 10 boxes. So total 60 eggs and 10 boxes. So first we can take x is a random variable. Number of eggs broken. So we can take all eggs. All eggs means first egg I represented E1. First box eggs I represented E11, E12, E13, etc. E16. Second box contains 6 eggs. So that also I represented E21. So here E11, etc. E16, 6 eggs. Next E21, E22, etc. E26. Similarly, we got E66, 60 eggs. So the number of outcomes, 60 eggs we have. These eggs, all eggs are good except 60th egg. 60th egg is broken. All others are good. That is the one possibility. Other one is all are good except E59. It's broken. E58 and E60. All others are good. So we got one egg is broken. We have an outcome, one egg is broken. So that is mapped to 1. No egg is broken. All eggs are good. So that is mapped to 0. Similarly, we can say 60th egg and 59th egg is broken. All others are good. Similarly, 59th and 58th egg are broken. All others are good. 2 eggs are broken. So we can map it to 2. Similarly, 3 eggs are broken. Similarly, continuing, 60 eggs are broken. So we got the number of broken eggs variable is, say, function from set of false outcomes to real number. That image set is 0, 1, 2, etc. 60. Okay. Next, y is number of rejected box. The number of rejected box. So we have similarly B1, B2, B3, extra B10 boxes. Okay, B10 boxes. So we can reject no boxes. We can't reject no boxes. So all eggs are good. Then we didn't reject boxes. So 0 boxes rejected. That is a one possibility. All boxes are B1, etc. B10. All boxes are good. All boxes, eggs are good, not broken. So we can map it to 0. Then one box is broken. Can be B10, can be D9, can be B8, can be B1, B2, B3, B4, B5, B6, B7. Any of the 10 boxes, one is broken. So we can say B1 etc. B9. B10 is broken. B1 etc. B8 and B10. B9 broken. B9 box have a broken egg. So one box containing broken egg. So that mapped to 1. So one box is rejected. Similarly, we can reject 2 boxes. Similarly, we can reject 3 boxes, 4 boxes, 5, 6, 7, 8, 9, 10. So rejected box, number of rejected boxes is a random variable from number of boxes outcomes, number of rejected boxes outcome to real numbers. And y of x can be 0, 1, 2, etc. 10. Not 6, etc. continuing 10. So these are the two outcomes related to 6x in 10 boxes. Okay. Other one of the example, year that a random student born in our class. So years. So we have a students, S1, S2, etc. 40 students. In this class have 40 students. So we take 2000 to 220. 2000 to 2005. So we can map the 2000 born students. So S1 to S5 or 2000 can be mapped to 2000. Others are 2001. So we can map it to 2001. So similarly, year of students born in our class is a random variable. Next, number of customers arrive at a service station at particular interval of time. So we can take each of 1 to 2, 2 to 3, 3 to 4. So number of customers can be 0, can be 1, 2, 5, 8. So these can map to any real number. 2 to 3 also map to real number. 3 to 4 also map to real number. So number of customers arriving at a service station at a particular time is also a random variable. and transmission time of a message in a communication system. It's also a random variable. So these are the random variables. Random variables can be divided into two. One is discrete random variable, other is continuous random variable. These two division is basically based on the cardinality of the range of a random variables. Discrete random variable. It is a random variable whose values is obtained by counting. Range of function from sample space is countable number. Then it is called discrete random variable. Cardinality of range of a function from sample space to real numbers is countable. Such type of random variables is called discrete random variable. So we can take about number of heads. We have a coin. That coin is tossed 6 times. Number of heads. That heads is 1, 2, etc. 6. So the range is countable. So this random variable is countable. Number of hit 20 free throws. So we have a ball. That balls throws 20 times. So that hit on a ball no times, 1 time, 2 times, etc. 20 times. So these also discrete random variable. Number of customers who arrive at a bank 8:30 to 9. So number of customers are countable. So 10 customers, 100 customers, 200 customers. So that also discrete random variable. So discrete random variable is an integer random, also called integer random variable. That means random variable, we already said that that is a function. That random variable is an integer valued function. Such is called discrete random variable. So that is a particular type of random variable. That is a special case of discrete random variable. Okay. Random variable that comes more naturally integer valued. So the integer values x of s is integer. That is also a random variable. That is also a discrete random variable. This is the special case of random variables. Next is continuous random variable. Continuous random variable is also a one of the random variable, but its outcomes has infinite number of possible values. Continuous random variable are usually measurements. A continuous random variable takes all values in interval of real numbers. Continuous random variable. So image of that random variable is continuous way. That means image of random variable is an interval of real numbers. Okay. So continuous random variable, range of continuous random variable can be A to B, this interval, or 0 to infinity, or minus 0 to infinity, or minus infinity to infinity. These intervals, the range of continuous random variables is an intervals. So example is height of a student, weight of a student, temperature of temperature in Kerala is a continuous random variable. Etc. be the continuous random variable. Okay. So in this section, I will explain what is discrete random variable and what is continuous random variable and what is the meaning of random variable. So I think all of you understand this section. I will continue other probability topics.